Hi, I'm Mohammed Hussein, a computer science student at MSA University. Today, we'll explore the decrease and conquer strategy in algorithm analysis and design. Our agenda includes an overview, algorithm design exercise with analysis, and a practical game to enhance understanding. Let's get into it. Decrease and conquer represents a problem-solving strategy within the realm of computer science. It involves the resolution of a problem through a process of segmentation into sub-problems. The approach entails solving one segment of the problem and subsequently applying the same method recursively to the remaining sub-problems. The fundamental concept revolves around systematically diminishing the size of the problem until a predefined base case is attained. This base case can then be directly addressed and solved. Let's get an example. Our example is Lomuto Partition Algorithm. Select a pivot element from the given array, utilizing it to divide the array into two partitions. Initiate two pointers, denoted as I and j, with I indicating the first array element and j iterating through the array starting from the second element. Traverse the array using the pointer j. If the element at index j is less than or equal to the pivot, interchange the elements at indices j and I, then increment I. Continue this iteration until j reaches the array's end. Perform a swap between the pivot element and the element at index I, the position where the pivot logically belongs. At this point, the array is partitioned into two segments, elements less than or equal to the pivot on the left, and elements greater than the pivot on the right. Apply the same partitioning process recursively to both the left and right subarrays. In this code, we have two functions: Quicksort Lomuto and Lomuto Partition. Quicksort Lomuto. This function is the main entry point for the Quicksort algorithm. It takes an array and the indices start and end that represent the range of elements to be sorted. If start is less than end, the array is partitioned using the Lomuto partition, and then the function is recursively called on the left and right subarrays. Lomuto partition. This function performs the Lomuto partition on the array. It takes the array and the indices start and end. It chooses the pivot element. In this case, the last element of the array is array of end. It then rearranges the elements in the array so that elements less than or equal to the pivot are on the left, and elements greater than the pivot are on the right. The function returns the index where the pivot ends up. Let's get into the analysis. First, we have t of n is equal t of n minus 1 plus n. The t of n minus 1 is equal t of n minus 2 plus n minus 1. Now the t of n equal t of n minus 2 plus n minus 1 plus n. The t of minus 2 equal t of n minus 3 plus n minus 2. So, the t of n is equal t of n minus 3 plus n minus 2 plus n minus 1 plus n. It looks like we found a pattern, then we generalize. First, we find the base case. When n minus k equal 1, it means it reached the base case and the k is equal n minus 1. Because we are subtracting 1 in each recursive step until we reach the base case. Now our t of n is equal t of 1 plus n minus 1, and so 1 until 2 plus 1. The final t of n is equal to a of 1 plus n. Multiply n plus 1 over 2. Which means the worst-case time complexity for the Lomuto partition quicksort is O(n) squared. Let's play a game to see how this algorithm works. Apologies for not playing the video due to copyright restrictions. Kindly find the link in the video description. To sum up, Decrease and Conquer provides a methodical problem-solving approach that systematically diminishes a problem's size until it reaches a trivial state. This paradigm, as demonstrated by algorithms such as Lomuto partition and Quicksort, not only improves efficiency, but also fosters elegant solutions. Its recursive nature establishes a flexible framework capable of addressing a wide array of computational challenges in the field of computer science. Thank you for watching. If you have any question, please contact me at mohammed.hussein20@msa.edu.eg and take a look of my portfolio. I'm going to leave it in the description.